think what the next project is going to be, now that I have the coin box hopefully fixed, is I want to try and make a T-slot block for in the table saw, because I realized while doing the last project that trying to do thin rips on little tiny things on the table saw is scary at best and dangerous for sure. So rather than doing it that way, I'm just going to try and make a thin rip jig. Now yes, I can probably do these tiny things on the bandsaw. That would be another option and that would be safer, but I want to try and make, well, I want to use the lathe for stuff, specifically the milling attachment, since I have all those parts and haven't tried that yet. So I figured, all right, we'll try that. So I have these pieces of aluminum that were extra bits from when I did the drill press holder table that I made. I have Sharpie, which kind of works as a layout fluid in a strict sense of the word. Plan is I have 1 inch by 0.625 inch block, and the slot is 0.962 wide on the bottom, as best I can tell with my calipers, 0.15 from the bottom to the top of the T-slot type section. It is 0.7545 wide at the top section, 0.42 total width. So this is going to be taller than I need, which I might need to then shorten that, but that's fine. I'd rather have it a little bit taller. I can deal with taller easier than too short. So we're going to just leave it the full height, which is 0.6. Worst case later, I can put it back and just take a section of the top off. I think that should be possible. We're going to try it. If it doesn't work, I have extra. I can always try it again. So the plan is to try and turn this bar, which is 0.625 thick by 1 inch wide, into a 0.94 wide, which is less than the 0.96, so it has a little bit of room at the bottom. And then maybe I should be 0.95, but anyway, it's a test. 0.145 tall for this bottom part, so that will fit fine in the 0.15 or 145, and then 0.71 wide at the top versus 0.75. So that will be a bit of play, but hopefully not too much, but enough to work. So we're going to try. So I have this little chunk, and I tried to make some layout lines using the calipers. So we'll see how that ends up working. So next I got to get the lathe set up because it's currently in a storage position versus a usable position. Alright, now that I got it set up, let's try it and see how it does. So this is a 1/4 inch bit with a 3/8 inch shank in there. And this is 8 times speed. And it just slowly chewed through. So this took me, overall this video clip was 27 minutes for the time lapse. Shrunk it down to 4 or so, 3 to 4, but that's all right. So this first section, I'm just testing to make sure things work and reducing the overall width so that we go from the 1 inch to like 0.9 something. And here I realized that, hey, it's going up and up and up because it's doing the climb cutting for that direction. So I learned, don't cut it in that direction, which is fine. But I also realized that I don't know how to lock the vertical flow or the vertical movement. Maybe it's that one screw next to the bolts there, but I don't know how to lock that. So for the rest of the video, I held my hand on it so that it didn't go up and down and stayed where I needed it, because for these cuts, I was actually trying to do the actual T-slot piece versus just cleaning up the whole side. The first part where it did that didn't matter because I was just literally taking the entire side off. Here, I'm trying to only go down to a certain height so I can get the T-slot in the right height. And this is all just visual because I don't have the measurements or didn't set up measurements to do it. I just lined up by eye to the scratch marks that I put on there. And at the end, it ended up working, so that was cool. So one of the sides is done for the T-slot, and then it's like, okay, how am I going to get the height the same? And it's like, wait a second, I didn't change the vertical height. If I just do the lower one first, that should be the same height as the other side, so that's why I did it this way. And that worked out. And you'll see here in a second, I ran into something else, but it's the whole learning thing, right? Learning is good, and going back across smooths that off and gets a better surface. So that's nice. And then I came back and tried to do it again, and got a little bit, and then it stopped going. What the heck? Okay, that's not good. Get it out. Stop things. Try and spin it manually. And say, hey, a second, that's not spinning right. Aha. That pulley's loose on the shaft. That would do it. I never tightened that up, so I guess it just finally worked its way loose. Hopefully it didn't mess up the shaft. I didn't take it off to check it. I just went and managed to find the appropriate Allen size that I got with the lathe as one of those little tools, and tighten that up. Double check it again, make sure. There's 2 different set screws, so that's at least good for that. It spins nice now, so let's try it and see. Yeah, it spins. So there we go. So let's keep going. So go back through. And that's all going. Last piece coming along. Very nice, very nice. Get that all out. All right. Now let's file it up so there's no sharp edges. Alright, well, as a first test, that came out pretty cool. I don't know if it's going to work, but it came out pretty cool. So as you saw, first I faced off the whole one side to get it down to the narrower width. And then I worked on taking off the sides for the dovetail piece, and it looks like a T-slot. Or I guess not, it's not a dovetail piece, it's a T-slot piece. Nice little pile of chips. That worked. The only issue I had is I didn't realize that this pulley was loose. So it loosened up during the thing, and it's like, wait, did I catch it? And then I realized it's spinning on there. So stopped everything, tightened that up, and then it was running again. Otherwise, I think that worked pretty cool. So let's see this sizing, see how close I got. All right, so, or how close to what I had attempted to get, because it was all visual versus anything precision. So, all right, I was aiming for 0.71 for the width of this. So let's see how I did there. 0.72554. There's 0.71. Yeah, I did notice that. Yeah, so it's not, the way the setup was, I don't think it's completely cutting square the whole way across. I think that there's a little bit of an angle in the table, meaning I'm not 100% sure that this is actually on 0, and I'm also not sure that I didn't get chips or something in here. This is not a precision. For all I know, this thing's different widths on the 2 ends, so having that in there as a spacer, that by itself may have thrown it off from 0.71 something to 0.72 something, but that's all right. And it looks like this little tab is narrower than this tab on this end, and it's the same on both ends. So this one is wider, or this lobe of the T is wider in this direction, or longer in this direction than this one by a slight amount. So let's see, how did I do for the overall width? I was aiming for 0.94. 0.943 on that side. 0.96. 0.94. So it goes 0.9435 on this end to 0.956. It's not a precision part. It's just a T-slot thing. So let's see. I haven't tried this yet. Let's see if it fits. I don't know if it will. Looks good from the top side. Will it go in? Hey. That's what we needed. It wobbles a slight amount, but that's fine, because when you pull up, it would tend to not do that. That does everything I needed to do. So that was a successful test. It goes in the T slot, and it turns out those lobes are fine. Yeah, that's awesome. So there we go. The first milling attempt was a success. So we went from this to this. Very, very cool.